Good morning.
Good morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Okay, so we are going to discuss the steam power plant layout. So during the introduction class, I have shown you the layout of the steam power plant. So again, I'm going to show that layout of the modern steam power plant. So here you will have the different circuit. Uh, that details of that four circuits we are going to discuss. If you are observing, this is a boiler, and it is the generating the steam. Uh, Suppose that is the saturated steam, again it is going to the superheater, then it is given to the steam turbine, where you will have the expansion of the gases or steam, and that will be mechanical shaft work will be given to the generator, where it will generate the electricity. So continuous process is there. So as we are going to discuss the different circuit. The circuit names are your coal and ash circuit. There we are discussing the four different types of circuit. So what are those circuit? Okay, so modern power plant, we will have the four different circuit. Means there the four different uh, major person we are going to discuss here. The first one is the coal and ash circuit. Then we are having the air and gas circuit with water and steam flow circuit, cooling water circuit. So here, if we are observing, this is the coal and ash circuit. So this person is your coal and ash circuit, right? Uh, okay. So here, if you are observing the coal and gas circuit, means it will here in this case we are going to discuss about the how that coal will be transported. And that is prepared for the furnace, and where it can be storage, and there we are performing the different handling system. That handling means that we are again preparing the size of the coal, reducing the size of the coal as per our requirement. Okay, so that coal will be fed to the furnace, and where that will give the hot gas to the boiler, which will boil the water, and that steam will be generated. So the lead ash will be collected at the bottom of the grate. Okay, so that ash will be collected by the ash handling plant, and because that is at the particular temperature, and that is also corrosive one. So we should take care of that one, and that will be handled by the handling plant, and then it will be storage at the case of the as storage. Okay, so the in case of the uh, coal circuit, There we are having the different fuel feeding device or coal feeding device, right? So in case of the ash handling system, so there we are having the different ash handling equipment. So we will discuss one by one in detail. So it is all about your coal and ash circuit. Then we are going to discuss the air and gas circuit. So, if you are observing in this case, so here we are having the air in, which will be entered to the air preheater. In case of the air preheater, we are having the hot gas, which will go to the chimney through the air preheater. So that hot gas will hit the atmospheric air, and that preheated air will be given to the furnace for the air circulation for burning purpose. Okay. So in case of the AR circuit, here you will have the equipment is the forced or induced draught fan. Here you can use the FD means it is the forced draught fan, or we are using the induced draught fan, right? So then it will go to the furnace by passing through the ARP heater. So as I already told you, it will be heated by some the hot flue gases, which is going to the chimney via preheater. Okay, so this is the AR circuit. Now we are going to discuss the uh, gas circuit. Okay, so gas circuit means here it is the gas circuit. So it will go to the superheater, so where that saturated steam will be uh, become superheated by exchanging the heat from the waste heat, that is the flue gases. Then that flue gas will go to the economizer, where that feed water will be heated in this economizer. Then it will go to the air preheater. It will heat the air in this air preheater. Then it will go to the chimney. So in before going to the chimney, there we will have some the precipitator or dust catching devices, right? Or precipitator will be there, or fly ash collector will be there. Okay, so then it will go to the atmosphere. So why we are using all these dust collector, dust catching or precipitator or your device? The reason is that if there will be some the dust particle, so that should not be directly given to the atmosphere as per the rule of your climate or environmental pollution. So they should collect it before the chimney itself, and that will be uh, dumped to the outside during the non-operation time. Okay, so this is all about your air and your gas circuit, right? So now we are going to discuss the feed water and steam flow circuit. So first one is the steam flow circuit I'm going to discuss here. So this red line is related to your steam flow circuit, and this blue line, this is the blue line, so this is related to your feed water circuit. Okay, so in this case, the steam will be generated from the boiler, that will go to the superheater. Then superheated steam will be generated, and in case of the steam turbine, that will be expanded, and it will go to the condenser. So if you are observing in this case, so here we are using some amount of steam for the heater, that is a low pressure low pressure feed water heater and high pressure feed water heater. That is the cogeneration we can say. Okay, so that it will be collected from the in between the expansion process, and that feed water temperature will be increased in this feed water heater. So the exhaust from the turbine, that steam will be entered to the condenser, and the condenser will form the condensate by exchanging the heat with the outside water, that is the cooling water. So that cooling water circuit I'll discuss later on. So then it will go to the low pressure feed pump. So here we are using some of the makeup water or what makeup water from the liver a river, or it may be collected from the sea, or it may be collected from the lake. So that water will be given to this water heater, and and then it will pump to the deaerator. Deaerator, I have already told you what is the function of the deaerator. It will be uh, it it will remove the dissolved gases. Then it will go to the high pressure feed water with the help of the another pump. So then there will be the temperature of the condensate will increase up to the temperature of certain limit. Then it will go to the economizer. In case of the economizer, it will exchange the heat with the flue gases. The water temperature, feed water temperature will increase, and it will be the preheated water. Then it will be given to the boiler. Okay, with the desired pressure and desired temperature, so that the whatever amount of fuel is required to generate the steam, that will be reduced. So likewise your plant efficiency will increase. Okay, so this is all about your steam and feed water circuit. Okay, red and blue circuit line. So then we are having the cooling water circuit, so which is the last one. So in this case, if you are observing, this is the cooling water circuit. So here we are going to discuss the cooling tower and your spray pond. Okay, so cooling water supply to the condenser will be given by the out this arrangement, or spread or cooling water arrangement. So that will maintain, that cooling water will maintain the low pressure in it. Okay, so that cooling water will be collected from the natural source. From natural source means from the lake, sea, or river. Okay, so this will be circulated over and over again, over continuous process. Okay, so this arrangement will be discussed in detail in the another chapter. So this is all about your core circuit, which I have discussed to you. So now we are going to discuss the what are the components of the modern steam power plant. So components means, if you are observing in this case here, the details are given. It is the first main component is the heart of the steam power plant is your boiler and your steam turbine. So boiler means, in this case we are going to discuss the different types of boilers, and then the other components are your superheater, reheater we are using, right? Then economizer and air preheater, and your steam turbine, generator, condenser, cooling tower. Then we are having the circulating water pump, feed water heater. There are other equipments are also, like your wagon tripler, which will be used during the coal handling system. Coal mill will be discussed in this case. Crusher house, induced fan, forced drop fan, precipitator also the one kind of component of this power plant, and water treatment plant, and there will be the switch yard are available in case of the modern power plant. So these are the components of the components of our modern steam power plant. Okay, so now we are going to discuss the selection of the um, selection site for the steam power plant. So, what will be the points which we will consider to select the site for the uh, steam power plant? Okay. So different points we are going to discuss here. The first one is the availability of the raw material. So first one is the availability of the raw material. So if we are discussing any modern thermal power plant which will generate the 400 megawatt of capacity, the steam generation capacity or the power generation capacity. So it is the power 400 megawatt means it is the power generation capacity. So it will require generally approximately that has been taken as 5,000 to 6,000 tons of coal per day. Okay, so this much of the coal will be used to generate the this amount of electricity. So, in case of the thermal power plant, there may be the two to more than 2 to 3 unit as per the types of thermal power plant used. So, as per the capacity of the thermal power plant. So there may be the 2 to 3 units which will generate the 500 megawatt or 400 megawatt as per the demand that will be designed. So the minimum of this amount of coal is required to generate a 400 megawatt of capacity. Okay, so in that case, the first thing we have to keep in mind is that availability of the raw material. So there should be the plant should be located the place near to the ability of your raw material or apple or you can say the benefit of your transportation. Okay, so that plant should be mm, mm, placed or built near the coal fields in order to save the your transportation charge. Okay, so that is one thing. So in case of the nowadays there is the uh, if it is a coal plant, then you have to locate the plant near to the coal fields or where your transportation facilities are available. If it is the your liquid means diesel power plant, so that should be placed near to your supply of the liquid fuel means petrol bunk means where your liquid fuel will be easily available. There you can place your plant. So the uh, mm, that availability of raw material is very much important in case of the selection of the site of the steam power plant. So second one is So second one is your nature of your land. Nature of land is very much important in this case. The uh, which will depend upon the bearing capacity. Okay, bearing capacity. So the land which will have the good bearing capacity is used to withstand the dead load, dead load, dead load of the plant and the forces of the foundation which will be generated. So I'm not writing, which will be generated by the operation of the machine. Okay, so the nature of the land should be the will have the good bearing capacity, which can resist, which can withstand the dead load of the plant and the forces which will be transmitted to the foundation due to the running of your different machines. Okay, so this is the one criteria to selection of the site. Next is the cost of the land. So it is understood so that the cost of the land should be reasonable one. And it should be near to your cities also and near to the uh, load center, and it should be near to the water supply system also. We should choose the plant such a way that cost should be reasonable one. If we are considering um, the cities for the transportation as a load center or for the water supply. Okay, so then there is the fourth point is your availability of the water. So availability of water means in case of the cooling tower, if you are observing, there should be the continuous supply of the water so that it can be used in case of the condenser. So if the large quantity of water will be used in this case. So for that reason, that plants should be placed near to the ability of the water, means it will be near to the river, or it may be near to the lake, or it may be near to the pond, sorry, sea, so that it can supply the large amount of water. Okay. So, in case of the ash handling plant, or there also we have to require the large quantity of water for the disposing of this as. So hydraulic systems are used in this case, so there also it will be required. So the for that reason we have to locate the power plant near to the water source. Okay, so this is the fourth point. Then we are having the fifth point, that is the transportation facilities. So availability of the proper transport facilities is another important point. So where that thermal power station can be located. So generally, railway system or railway transportation systems are mostly used in case of the steam power station or thermal power station to bring the heavy machineries for the installation and to bring the fuel or coal to the site. So then we are having the sixth point. So the sixth point means here we are having a ash disposal facilities. So the as for the pollution control board or atmospheric pollution or soil pollution, that environmental control pollution control board, they have uh, uh, given certain rules so that it should not affect the human health, or it should not be corrosive one. So in case of the as handling system, generally we are handling the hot as and as well as highly corrosive as. So there should be the sufficient space uh, should be there near to the plant, so that that large quantity of ash can be disposed. Okay, so in case of the 400 megawatt capacity of power plant, there it will require generally 10 hectares area are required to dispose this as. Okay, so this is the requirement. So there are other requirement also. 4.6. Okay, so 7 point is your availability.
So, ma'am, ash is put as landfill around the plant.
G, tell me again.
Ash disposal is done by filling the land, or huge holes are dug up and then the ash is
So
disposed there.
nowadays these as are used to prepare the bricks also. So previously in the
Okay.
thermal power plant, it was the big issue. So I think 10 years before, it was the issue for the thermal power plant where it will be disposed. So they have the site near to their plant, but after some year it was the full. So generally they were disposing to the outside of the cities or near to the areas of your jungle. They will take the permission to dispose all these things. But nowadays the solution is there, means people are using this as for making some bricks and other preparation also. So in case of the plant, they will have the location where they will dump it and they will storage it. Storage means they will have the, as you told, they will dig and there they will keep it, and it will be up to the certain height. Okay, the dumping will be up to the certain height. After that, they will not do. They will choose another location near to that thermal. Okay.
Okay, ma'am.
So all of you have seen, I think, that that bricks which will be made from the ash. They will make it by using some clay and ash, some proportion of ash. Okay, I think. Okay, next is your availability of the level. So during the construction, all of you know that there will be the requirement of the labor. Also, the continuous operation of the power plant, you will have the requirement of the labor. So that near to that site, there should be the availability of the required amount of labor as per the uh, uh, um, as per the site, and in case at cheap rate. Okay, so their availability should be at the cheap rate. So 8 point is your size of the plant. So size of the plant means generally we are we are having the small capacity plant and your large capacity plant and medium capacity plant. So small capacity plant means there we are having the minimum two unit or two equipments uh, equipments to generate the electricity. So in case of the small capacity plant are used for the small load purpose. So in case of the small capacity plant, generally we are installing the two units of equipment. So these are designed as per the maximum demand of the as per the maximum demand. So if one unit is failure, in that case another unit will be run to supply that maximum demand. So that is your small loads or small capacity plant. Then we are having the medium, medium, medium capacity plant. So medium capacity plants usually it will have the more than two units of more than two units of equipment. Here the requirement is your maximum demand as well as the large electrical generation or large capacity of units. So that is your medium capacity plant. So then we are having the large capacity power plant. So in this case, that steam turbines are of bigger size. So there we will have the number of unit is more, and this plant will be designed or designed to give the peak load, and that peak load will be adjusted as per as our requirement. Okay. So during the overloading conditions. So in this case, generally the turbine steam turbines are overloaded. That means steam turbines that will be overloaded for 10 to 15% of the rated capacity. So as per the capacity of the plant, we have to choose the site. So if it is a small capacity, it will require the less space as per this large capacity plant. Okay. So then we are having the load center.
मैम मैम यहाँ पर पीक लोड इलेक्ट्रिसिटी कंजम्पशन हो गया ना, जो इलेक्ट्रिसिटी टरबाइन बनाएगा।
हाँ, यहाँ पे जो स्मॉल कैपेसिटी, मीडियम कैपेसिटी और लार्ज कैपेसिटी प्लांट का मैं डिस्कस कर रही हूँ, ये आपका पावर जनरेशन का है, कितना वो जनरेट करेगा और कितना सप्लाई हो रही है। स्मॉल कैपेसिटी प्लांट जनरली स्मॉल इंडस्ट्रीज में यूज होती है, जो कि अपने इंडस्ट्री को ही देती है पावर जनरेशन। मीडियम कैपेसिटी जो कि एक सिटी के लिए यूज होता है। लार्ज कैपेसिटी मीन्स इट विल बी सप्लाइड टू द डिफरेंट सिटी। आई अंडरस्टूड?
यस मैम।
Okay. Then we are having the load center. Load center means in this case the power plant should be located near to the loads where it can supply the power to the power stations, and from there it will be supplied to the different places. So if you are observing this figure, this is the figure for the load center. So here two arbitrary axes we have taken. Suppose it is giving this amount of power generation. So the distance is given this one. And so this is the location of the load center. So it will have the direction from the different places. Okay. So the power plant should be located as far as possible to near to the power near to the load center or power transmission system, so that it can minimize the cost of transmission lines. Losses are there, right? Due to the long supply of the electricity, there will be the losses, so that can be also reduced. So we have to locate the power station in such a way that should be near to the load center. So these are the arbitrarily the CG has been chosen, and as per that one, the load center are given. So that should be near to the power station to minimize the transmission lines, cost of the transmission lines, and to minimize the losses. Okay, so there are the other things also. The 10 is the public problems. Yes. No, I think no, no, no. There, why during the furnace, they have to give the more energy to burn the coal. So better to locate it to the one warmer place, so that whatever energy will utilize in the furnace, that will be reduced. That may be the one reason. But in our India, such problems are not there. Okay. So public problems means in that case, as you all know, this thermal power plant, this will um, adjust the smoke and fly as smoke to the atmosphere, right? So there should not be much problem to the public, so that they will create any problems. Okay, so the fly ash disposal will be also there, and heat will be also discharged to the atmosphere, so that will give the public issues. So for that reason, so that thermal power plant that will be placed away from the towns or cities. Okay. So 11 point is your future extension. So one should keep in mind that the plant which will be designed at present. So in long future, that equipment sometimes that will be not work properly. So you have to install the number of units. So in that case, there will be requirement of the future expansions. So that should be the one kind of choice of the site, choice for the site. So these are the different points as I have discussed, which will keep in mind to select the site for the steam power plant. So already I have told you the capacity of the power plant. So here I have forgot to inform you that load center or this capacity of a plant, both they will consider the load curve or load duration curve. Okay, load duration curve. So what is that one? So the load uh, it is the uh, graphical representation of the load with respect to the time. So if it is the load and if it is the time, so for the plant, generally we are drawing the daily load curve. Okay, daily load curve means for the 24 hours running of the plant, what is the load required, what is the output of the plant required, that will be given in the graph. Suppose I'm taking the example, suppose at the 6 a.m. The load is, let us take, this is the minimum I'm taking. So for example, it is 6 kilowatt. So similarly, at 8 a.m., again we are taking, it is 8 a.m. So let us take that is 10 kilowatt. So in a day, the what is the amount of load or energy consumption required? That will be given in the plot, which can be understood by the plot or graphical representation, that is known as your daily load curve. What is the load duration curve? Load duration curve means for particular time period, there will be the continuous consumption, a particular amount of electric consumption will be there. So that will be given in the graph. So that is known as your load duration curve. So load duration curve अगर हम discuss करें, let me draw this one. Okay. तो मान लीजिए 6 आवर के लिए, 6 आवर के लिए हमारी मैक्सिमम डिमांड हो रही है 18 किलोवाट। मान लीजिए ये आपका 5 आवर के लिए हमें जरूरत पड़ रही है, ये है आपका 16 किलोवाट। सो पर्टिकुलर टाइम पीरियड के लिए कितना लोड और एनर्जी कंजप्शन यूज हो रही है, so that will be given in the graph, and this is known as your load duration curve. Okay, got my point. So this will be drawn in such a way that there will be the continuous decreasing condition. So this is the load duration curve. And daily load curve क्या है, एक particular time में कितना load requirement हुए है, उसके बोल रहे हैं. So as per that one, this plant will be designed. Okay. So this is all about your site selection. Then we are going to discuss the fuel handling system. So the
Ma'am,
first one is the coal and air circuitry. Yes, please.
ma'am, how is load center related to this curves, daily load curve?
Okay. This one.
Yeah,
This one
ma'am.
or this one.
How are they connected with load center?
लोड सेंटर के साथ कैसे कनेक्टेड है?
मैम आपने तो उसके सब टॉपिक में बताया.
Okay. Okay, so this load center means if it is related to the small plant or medium capacity plant, or what you can say, large capacity plant. So for large capacity plant, that load center will be the particular region load curve. So you are telling this one how it is related. Okay, so this it is not exactly related to the load center. It is related to this small capacity plant and medium capacity plant and large capacity plant. Okay, so which will depend upon the peak load, maximum load, or base load. Okay, so it is closely related to this plant capacity. Okay, this load curve.
Ma'am, one more thing. All the power lines are connected via the central grid nationwide. Then why is this load center term important if one has to set up a new power plant?
Yeah, it is important.
How? Because everything is connected to the nationwide central power grid. So just put the power input in the power grid and it will transmit somewhere.
Yeah, but near to that grid, near to that power station, if it is going to the power grid, right? You are telling about that PGCIL. No? They are taking the electricity from that thermal station only. That thermal station, they nearby there will be the load center, which will directly it will give to that load center. That load center will be for that power plant only. Then it will be distributed by the transmission line agency, that is the power grid agency. Okay, so that should be located near to that power generation unit. The reason is that it will be minimize the cost of transmission line. Another one is the losses which will occur during the transmission. Okay, पावर
Yes.
प्लांट का भी खुद का एक लोड सेंटर रहती है. Then only they are transporting to the different places by the help of the transmission agency. ओके, पीजीसीएल खुद का नहीं रहता है वो अब पावर जनरेशन यूनिट से वो अपना खरीदता है, फिर उसको ट्रांसमिशन डिफरेंट प्लेसेस को ट्रांसमिट करती है.
Okay, ma'am.
सो लोड सेंटर खुद प्लांट का एक रहता है, वो ज्यादा डिस्टेंस में नहीं होना चाहिए. इसमें तो फिर भी तो ट्रांसमिशन का कॉस्ट भी इंक्रीज हो जाएगा ना. खुद का जो पावर जनरेट कर रहा है उसको भी तो रखना पड़ेगा ना, ग्रिड रहेगा, लोड सेंटर रहेगा.
मैम मतलब जो सप्लाइंग ग्रिड है उसके क्लोज होना चाहिए पावर प्लांट.
हाँ,
ओके, अंडरस्टूड.
सप्लाइंग मीन्स आई एम नॉट गेटिंग यू.
मैम लाइक ऐसा फिक्स तो नहीं होता ना कि ये पावर प्लांट सिर्फ इस सिटी पे पावर देगा, क्योंकि वो तो बस पावर आउटपुट देता
हाँ
रहता है
हाँ, पावर
बाकी
आउटपुट
नीड के
देता
हिसाब
रहता
से.
है, वो डिपेंड करता है. देखिए कुछ कुछ हाइड्रो पावर प्लांट होती है एक सिटी में, पावर प्लांट भी होती है, थर्मल पावर प्लांट भी होती है, राइट. तो हाइड्रो पावर प्लांट वो जनरेट हो पा रही है, उसी के हिसाब से अपना सिटी चूज करता है या चाहे लोकेशन चूज करता है, उसी के हिसाब से वो डिमांड सप्लाई करता है, राइट. तो थर्मल प्लांट का भी है, थर्मल प्लांट भी वही करता है. हालांकि यहाँ पे आपका इलेक्ट्रिक जनरेशन ज्यादा रहती है, ठीक है. तो यहाँ पे वो अपना एक लोड सेंटर रहता है, वहां पे वो जितना इलेक्ट्रिसिटी जनरेट होती है वहां पे वो लोड सेंटर में रहती. फिर उसके बाद डिस्ट्रीब्यूट होनी चाहिए जितना सिटी को वो दे सकता है, जितना यूनिट का बना हुआ है, उसी के हिसाब से आजकल तो जो पावर ग्रिड है वो अपना सप्लाई करता है. और भी बहुत सारी कंपनी, छोटे मोटे कंपनीज भी हैं जो कि इसमें ट्रांसमिशन में भी आजकल जुड़े हुए हैं, वो लोग सप्लाई करते हैं. ठीक है, नाउ यू गेट माय पॉइंट. लोड सेंटर है वो प्लांट का खुद का लोड को स्टोर करेगा, फिर उसके बाद डिफरेंट ये को ट्रांसमिट जाती है, डायरेक्टली नहीं जाती है. समझ में आया? ओके. So next one is your fuel handling system. So fuel handling system means it is related to the coal handling system. So all of you know that there are the different type of power plant. So depending upon the fuel used, depending upon the types of fuel used. So solid fuel means we are using the coal fuel, and liquid fuel means we are using the oil. So generally those are your diesel fuel or petrol. Generally diesel power plants are available. And then there is the gaseous fuel. Gaseous fuel means here we can use the different types of gas to generate the electricity. So gas will be utilized in the prime mover, and uh, that will be given to the generator, and that will generate the electricity. Okay, so here we are discussing the steam power plant. So the coal is generally used as the solid fuel. So here it is the layout of the fuel handling. Okay. So fuel and handling is the important thing because here the maximum amount of operating cost will be involved while purchasing your fuel and while handling your fuel. So the total operating cost will be about 50 to 60%. So that's why we have to be more focused in case of the fuel handling system. Another things are your transportation system. So transportation system means it is related to the your sea transportation or rail transportation, or it may be the roadways, road transportation, or it may be the pipeline transportation. So there is a requirement of the good coal handling system or fuel handling system. The reason is that it should be required the minimum maintenance, it should be reliable one, and there should be the minimum operating cost. Okay, so also the quality of the fuel is also important, and size of the fuel or cargo is also important, which will uh, require during the running of the plant. So coal handling system or fuel handling system will have the different stages or different steps. So the first steps is your coal delivery. So coal delivery will be done from the location to the site with the help of the different transportation process. Then there will be the unloading process. Then there will be the preparation process. Then it will be transferred to the storage system. So that will be the out storage system. There will be the cover storage, and there will be the implanting steps. Uh, mm, implanting steps, implanting handling system. Then there will be the weighing and measuring. What is the amount of coal is used, the furnace that will be discussed in this case. Then there will be the furnace firing. So furnace firing means when it will be fired to the burn uh, that different equipments are used in this furnace firing system, which I will discuss in the next class. So this is all about the various stages involved in the coal handling system. So this one is the outline of the coal handling equipment. So here is the feeder. There will be the feeder. That feeder will be used to store the coal, and it is the live storage system. Different storage systems are there, which will be transferred to the conveyor belt, or different belt will be conveyors will be discussed in this case. Okay, so this is the outline. So first one is the coal delivery. So in this coal delivery, this is the first stage. So it is the supply points of the coal to the mm, delivery point, uh, where that will be done by the railroad or river or sea. So it should be situation, the plant should be situated near to the river or near to the location. Okay, so then there will be the unloading process. So the unloading process will be done by the if by the different handling mode or out plant handling mode. So those are your road, rail, or ship. So if the coal is delivered by the trucks, there is no need of unloading devices, because there are the lift trucks are available with the scoop, which can easily handle or deliver the coal, or it will also unloading that coal at the particular site. So if that unloading as coal transportation is done uh, by sea, or uh, by by ship, so in that case, the equipment which are used uh, used equipments are your portable conveyors, coal accelerator, coal towers, unloading bridges, self-unloading boat, self-unloading boat. Okay, so if the transportation of the coal is done by the sea or in that case, the unloading equipments are used are your portable conveyors and your coal accelerators, coal towers, and unloading bridges and self-unloading boat. Okay, so next class I will discuss in detail. Okay. Please respond to your roll call. Roll number 1,
Present, ma'am.
2,
Present, ma'am.
3,
Present, ma'am.
4,
Present, ma'am.
5,
Present, ma'am.
6,
Present, ma'am.
7,
Present, ma'am.
8,
Present, ma'am.
9, 9, 10,
Present, ma'am.
11, 12, 11, 11, 12, 13,
Present, ma'am.
14,
Present, ma'am.
15,
Present, ma'am.
16,
Present,
17,
Present, ma'am.
18,
present, ma'am.
19, 20,
Ma'am. Present, ma'am.
22, 22, 23,
Present, ma'am.
24,
Present, ma'am.
25,
Present, ma'am.
26,
Present, ma'am.
27,
Present, ma'am.
28,
Present, ma'am.
29,
Present, ma'am.
30,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Present, ma'am.
36,
Present, ma'am.
37,
Present, ma'am.
38,
Present, ma'am.
39,
Present, ma'am.
40, 41,
Present, ma'am.
42,
Present, ma'am.
43,
Present, ma'am.
43, 44,
Present, ma'am.
45,
Present, ma'am.
46, 47, 48,
Present, ma'am.
49,
Present, ma'am.
50, 51, 52, 53,
Present, ma'am.
54,
Present, ma'am.
55,
Present, ma'am.
56,
Present, ma'am.
57,
Present, ma'am.
58, 59, 60,
Present, ma'am.
61,
Present, ma'am.
62,
Present,
63,
ma'am. Present, ma'am. 63.
63, 64,
Present.
65,
Present, ma'am.
66, 7, 8,
Present, ma'am. 69 present, ma'am.
70,
70 present, ma'am.
71, 72,
Present, ma'am.
73,
Yes, ma'am.
74, 75,
Present, ma'am.
76,
Present, ma'am.
77,
Present, ma'am.
78, 79,
Present, ma'am.
80,
Present, ma'am.
81, 82,
Present, ma'am.
83, 84,
Present, ma'am.
85,
Present, ma'am.
86,
Present, ma'am.
87,
Present, ma'am.
88,
Present, ma'am.
91,
Ma'am.
92,
Present, ma'am.
93,
Present, ma'am.
94,
Yes, ma'am.
95,
Present, ma'am.
96, 97, 98,
Yes, ma'am.
100,
Present, ma'am.
101,
Present, ma'am.
102,
Present, ma'am.
103,
Present, ma'am.
104,
Present, ma'am.
105,
Present, ma'am.
106,
Present, ma'am.
107,
Present, ma'am.
108,
Present, ma'am.
109,
Present, ma'am.
110, 111,
Yes, ma'am.
12,
Present, ma'am.
113,
Present, ma'am.
114,
Present, ma'am.
115,
Present, ma'am.
116,
Yes, ma'am.
117,
Present, ma'am.
119,
Present, ma'am.
120, 120, 121,
Present, ma'am.
122.
Present, ma'am.
Thank you. Thank you. Thank you.
Ma'am, you didn't say
So
no.
ma'am,
Ma'am, you didn't say
120.
99 whole number.
99 skip कर लिए हैं क्या?
You